Hello students, welcome back to my channel. This is Harsh and in this video we will be discussing about exercise 5.5 of class 12th mathematics from chapter 5th. Okay, so let's begin with our with our 10th question. We have done till 9th question from the previous video. In this video we shall cover 10th to 18th question. Okay, so let's have a look at our 10th question. I am assuming the question as y and x cos x, x is to power cos x, x is to power x cos x plus x square plus 1 upon x square minus 1. So this is our question. Okay, I am assuming u as x is to power x cos x and v equals to x is to power x square plus 1 upon x square minus 1. This is our v, and we will differentiate these two functions differently. Okay, one by one. Okay, taking the log both sides, we have log u equals to x cos x log x. I'm straightly doing these questions because we have already done step by step in the previous question. Okay, and log v equals to log x square plus 1 x square plus 1 minus log x square minus 1. Okay, now we shall differentiate these two functions. In this function we will use product rule, and in this function we will be using normal differentiation method. Okay, so what is the differentiation of log u? Log u differentiation is 1 by u du upon dx, because we are differentiating with respect to x, and applying the product rule here we have x cos x upon x, which is only cos x. X is denoted by the x, and here we have cos x so see here we need to apply the product rule 3 times, because x cos x log x are the 3 different functions. Okay, now see here what I am doing. First of all, I am differentiating x. Okay, we have cos x log x. Then I am differentiating cos x, which gives us minus sin x, and x was already present there, that's why x as it is, and log x as it is. And this time I am differentiating log x, which give me cos x only. Okay, this is the product rule which is applicable on the 3 functions. Okay, here the 3 functions are x, cos x, log x. Okay, and if you want to understand about the product rule, go through your NCERT book. You will come to know about that product rule, how is product rule applied here. Okay, now next comes about this log v differentiation. Log v differentiation is 1 by v dv upon dx. Log x square differentiation is 1 upon it's log x square plus 1 and log x square minus 1. Log x square plus 1 differentiation is this, and x square differentiation is 2x upon x square minus 1. Okay, now we need to simplify these things, these two functions. Okay, here we have x is to power x cos x, because the value of u was x is to power x cos s, and when I took this u from division to multiplication, we have x is to power x cos x. Okay, and here we have cos x log x minus sin x log x. Here I have taken this x here. Okay, and plus cos x. Okay, so what can you take common from these 3 terms? I think nothing. We can't take anything common from these terms, so leave it as it is. Here we will simplify it, or we will leave it as it is. Okay. The value of v was x square plus 1 upon x square minus 1. I have taken this v from left hand, from division to the multiplication with this term, and here we have 2x. I am taking the LCM here. Okay, x square minus 1 minus 2x, x square plus 1 upon x square. Look here, what is this? How is this function looking? X square plus 1 and x square minus 1. How do you recognize this? What is the identity of a plus b and a minus b? You may be aware that a plus b and a minus b identity is a square minus b square. So I am writing the same thing here, which is x raised to power minus 1. Okay. So what I am doing here, I am just adding these two functions. Okay, cos x log x minus x sin x log x plus cos x, and this function I am writing here. Okay, with plus sign here, and x square x square plus 1. So let's look here, we can simplify it more. X square plus 1 and x square minus 1, x square plus 1 with this. Okay, this is deducted by this. Okay, we have 2x x square minus 1 minus 2x x square plus 1 upon x square minus 1 whole square. Okay, this was the answer of our 10th question, and this question is quite important from the board point of view. In fact, this complete exercise is very important from the board point of view. So I will rather prefer you to completely revise this exercise if you want to get 6 marks, because usually 6 mark question is asked from this exercise. Okay. Now let's have a look at our 11th question. But before that, pause the video to note it down. Now let's have a look at our 11th question, which is x. I am assuming this function as y, x cos x raised to power x plus x sin x raised to power 1 by x, taking u equals to x cos x raised to power x and v equals to x sin x raised to power 1 up by x. Okay, now we will differentiate these two functions one by one. Okay, taking log both sides, we have x log x cos x. Okay, the same thing here, we have log v equals to 1 upon x log x sin x. Now differentiating this function, we need to apply here product rule in between these three. Okay, these are the three different functions: x log x cos x. Students, don't make mistake of taking this as one function. Okay, and In log v the same here, three functions are also there. Now just see here, differentiating this function, we have 1 upon u du upon dx. Applying the product rule here, first of all differentiating x, we have log x cos x as it is, and when I differentiate x log x, we have only cos x, and when I differentiate cos x, we have minus sin x. I'll prefer to write x log x sin x. Okay, students, you need not to remember this three. If there are three functions, how will you apply the product rule? The simple funda is that take these functions one by one and apply it according to the product rule which you are applying in the functions in the two functions. Okay, the same thing I have done here. First of all, I differentiated this x and left log x cos x as it is, and then I differentiated log x and left x and cos x as it is, and I have deducted this x with the derivative of log x, which was 1 by x, and x was deducted by 1 by x. Okay, then I differentiated cos x. Cos x differentiation is minus sin x, the same I have written here, and x log x as it is. Second, 1 by b dv upon dx. 1 by x derivative is minus 1 upon x square log x sin x as it is. Okay, plus derivative of log x is 1 upon x square sin x. Don't misunderstood that log x derivative is x square. Log x derivative is 1 upon x, and 1 upon x was already present here, then that's why I multiplied x with x and I got here 1 upon x square. Okay, and the derivative of sin x is cos x. I have got log x cos x. Okay, so this was the derivative of this 1 upon x log x sin x. Okay, now we need to take this v and u to the multiplication here. Okay, we have, what is the value of u? The value of u is du upon dx equals to x cos x raised to power x, and here we have log x cos x plus cos x minus x log x. Okay, and if you nothing, this was the derivative of u, and here the derivative of v. dv upon dx is, the value of v is x sin x raised to power 1 upon x. Okay, in multiplication with minus 1 upon x square log x sin x in the multiplication, then we have 1 upon x square 1 plus x square sin x, and log x cos x upon x. Okay, students, don't think that you will deduct this x with this x square. Okay, this is wrong. Okay, you can't deduct this x with the x square, because this x is the angle of sine, and you know that the sine does not exist without its angle. Okay, so that would be invalid if you deduct this x with the x square. Okay, now merging the functions, or you can say that adding the derivations of the two functions, we have x cos x raised to the power x into log x cos x plus cos x minus x log x, and addition with x sin x raised to the power upon x into minus log x sin x upon x square, and then we have sin x upon x square in addition with log x upon cos x upon x. If you want to take out this x square common, this x form common from these three terms, you can take common, otherwise you can leave it as it is, no problem. Okay, so this was our answer of 11th question. The 12th question is very important from the board point of view as well as the competitive point of view. This 12th question just came in the 2020 NDA 2 and ND1 exam. Okay, and now let's move to our 12th question, but before that pause the video to note it down. 12th and the 13th question of this exercise are just similar. Okay, and which question should I take? Okay, in 12th question is a bit easier than the 13th question. I am taking the 13th question. Okay, and 12th you will try yourself. Okay, y raised to power x equals to x raised to power y. Okay, I'm assuming this y raised to power x equals to u equals to y raised to power x, and v equals to x raised to power y. The same thing I will do here. I will solve these functions one by one, and taking the log both sides, we have log u equals to x log y, or here we have log v equals to y log x. This question is quite easy and important as well. Okay, 1 upon u du upon dx. Okay, and x log y differentiation is x as it is, y differentiation is 1, and dy by dx, sorry, and this time x derivative 1 and log y as it is. Okay, see here, x and log y are the two different functions. Don't do the mistake to consider these functions as only one function. Okay, the same thing will be applied here. These are also two functions, and the derivative of log v is 1 by v dv upon dx, and y leaving y as it is, and y by x as a derivative. And here we have the derivative of y is again dy upon dx and log x as it is. Okay, what you need to do, just take this u to the multiplication here and v to the multiplication here. Okay, we have x dy upon dx plus log y in multiplication with this u, and which is y raised to the power x, and the value of v is x raised to the power v and y by x plus dy upon dx log x. Okay, what you need to find out? You need to find out the value of dy upon dx. Okay, so for that, what you need to do, just think over here. So think over here what we can do. Okay, so we have, from here we have two methods. We can take directly log to the both sides here and do the question from the starting, and here we can simplify this question as x dy by dx plus log y in multiplication with y raised to power x, and x raised to power y in multiplication with y by x plus dy by dx into log x. Okay, so I will if you will prefer this method of multiplication these two functions, you will get a very complicated answer, and the rest of the part will be quite tough. And another method, what you need to do, you simply need to apply log to the both the sides and solve this question out. I am telling you the second method, which is the quite easier. So for that I need to erase this. Okay, if you want to just write it down, you can write it here. Okay, I'm erasing this video. I'm erasing this board. Now just have a look at it, this 13th question. I'm doing this part by showing you just every single step. Okay, applying log both sides. We have x log y equals to y log x. This is what we have got by after taking log to the both of the sides. Okay, now differentiating these two functions. Okay, taking y x as it is and derivating y, we have x by y dy upon dx, and the x derivative is again 1 and log y as it is. Here we have in the right hand side we have y as it is, and derivative of log x is x, and now we have derivative y as dy upon dx log x. Now simplifying it, this method is quite easier than the previous method. Okay, so that's why I'm doing this method. Okay, now taking the terms which contain dy by dx to the one hand side and rest of the terms to the other hand. Okay, so I'm taking x by y dy upon dx minus dy upon dx log x equals to y by x minus x upon y. Taking out dy upon dx, we have x by y minus log x equals to y by x minus x by y. Okay, now what we need to do, we need to take this x by y minus log x to the denominator of this right hand side. We have x by y minus log x. Okay, if you want to simplify it, you can simplify, no problem. Y square minus x square upon xy upon x minus y log x upon y. Okay, so what you have left is, I'm writing here because the space is quite less. We have y square minus x square upon x into x minus y, x minus y will come into the denominator. We have x minus y log x. This is our answer. Okay, if you want to simplify it more, you can then also proceed with that question, but in case the question is given in the 4 marks, you can leave your question here. Okay, but if in case this question is given in the 6 mark question, you need to show that how many formulas you have applied and the steps you need to show them. Okay, so this was our 13th question. This question is quite important. I'm again saying that this question is quite important from the board point of view. So this was our answer. Okay, now pause the video to note it down. Now let's have a look at our 14th question, which is cos x raised to the power y equals to cos y raised to the power x. In the same thing you need to apply in the 14th question. The same logic will be applied in the 14th question which we applied in the 13th question. So let's have a look at our 14th question. Okay, taking log both sides. We have y log cos x equals to x log cos y. Okay, now take the we need to apply here the product will be applied and find out the derivation we have with respect to x. Okay, dy upon dx log x log cos x as it is, and then the derivation of log cos x we have. I will prefer to write minus here because cosine derivative is minus sin x. Okay, so y upon cos x sin x here. Okay, and here we have x as it is. Okay, I will prefer to find out the derivation of x first. Okay, log cos y, and then we have the derivation of log cos y is 1 upon cos y. Cos y derivation is sin y, and y derivation is dy upon dx. Okay, so this was the derivation of this x log x cos y. Okay, so now take these terms to the one hand side which contain dy upon dx. Here we have dy upon dx. Okay, log cos x plus tangent y. Okay, here we have log cos y plus y tangent x. Now I will explain you this, how did this log cos y plus y tangent x came here. Log cos y was already present here, so I have just taken this minus y sin x upon cos x to the right hand side, and you know that sin x upon cos x is tangent x. Okay, so the thing which I have done is just taken out common and simplified this question a bit. Okay, now dy upon dx equals to log cos y plus y tangent x upon log cos x plus tangent y. You can leave this question here only. Okay, so this was our 14th question of this 5.5 exercise. Pause the video to note it down, then we will proceed to our 16th question. I am leaving this 15th question for you guys. Okay, pause the video to note it down. Now here comes our 16th question. Okay, this will be the last question which I will be doing. Rest of the question, 17 and the question 17 and the 18th question you will be doing yourself. Okay, this is the 17th and the 18th question you have already done in the previous exercises. Okay, that's why I'm leaving these questions for you guys. Okay, and the 16th question is fx equals to 1 plus x into 1 plus x square, 1 plus x square into 1 plus x raised to power 4, 1 plus x raised to power 4, and in multiplication with x raised to power 8 plus x raised to power 8, and you need to find out f dash 1. Okay, first of all you need to find out the derivative of fx, then you need to find out the value of f dash x when x equals to 1. Okay, so this is the our 16th question. Okay, if you want to solve out this question, you can solve this question with the various methods. You have various methods to solve out this question, but I will rather prefer to solve this question by taking log. Okay, we have log 1 plus x plus log 1 plus x square plus log 1 plus x raised to power 4 and plus log 1 plus x raised to power 8. Now you can differentiate this. The question is a bit easier. 1 by 1 plus x plus 1 upon 1 plus x square. X squared derivative is 2x, and here we have 4x cube upon 1 plus x raised to power 4 and 1 plus 8x raised to power 7 upon 1 plus x raised to power 8. We need to find out the value at 1. Okay, so substituting 1, we have 1 plus 2, 1 by 2 plus 2 into 1 by 2 plus 4 by 2 plus 8 by 2. Okay, here we have 4 2 1 1. Okay, 1 by 2 plus 2 plus 4. Okay, we have 2 plus 4 6 and 6 plus 1 7. 1 by 2 plus 7, we have 15 by 2. Okay, so this is the value of our f dash 1. Okay, oh sorry, we made a mistake over here. F dash 1 is not this. What you need to take here is that you need to multiply this term again. Okay, I just forgot to mention this term in multiplication with this. Okay, I'm assuming in multiplication with fx. Okay, and this is in multiplication with fx, and the value of fx is 2 plus 2 plus 2 plus 2. 2 into 2 into 2 into 2. Okay, this is the value of our question. And here we have 2 to the 4, 4 to the 8, 2 to the 16, 16 to the 32, 32. 2 to the 4, 4 to the 8, 8 to the 16. Okay, here we have 16. We have 15, 8 to 120. So this is the value of f dash 1 at 1. Okay, I'm explaining you this question again because we made a mistake over here. Okay, so what I did in this question is basically we have considered this function fx equal to 1 plus x into 1 plus x square into 1 plus x raised to power 4 and in multiplication with 1 plus x raised to power 8. Okay, I've assumed this function as y, and in the likewise in the previous questions what we did, we differentiated y 1 by y upon 1 by into dy by dx. Okay, when we got 1 by y dy upon dx, I will assume this function as y. Okay, and after solving out this question we have dy by dx equals to y. Okay, you can do this here. I've already mentioned fx into multiplication with, you can write it as 8. Okay, and the value of y is this 1 plus x into 1 plus x square, that function, complete function. Okay, and we need to find out the value of f dash 1. Okay, now what you need to do, you need to substitute the value with the value of x with 1. Okay, when I substituted the value of x with 1, I got 15 by 2, and the value of y was 16, and 2 divided by 16 divided by 2 we got 8, and 15 into 8 equals to 120. That's our answer. Okay, so this was our exercise 5.5. okay,